The API server acts as the central management entity for Kubernetes, processing RESTful operations and ensuring communication between cluster components. Security is enhanced by implementing TLS encryption for all API traffic, ensuring data integrity and confidentiality. Controller Manager oversees core control loops to regulate the state of the cluster, handling node and job operations. Securing it involves configuring role-based access control, RBAC, to limit permissions and reduce the risk of unauthorized control. The scheduler determines the most efficient node to run unassigned pods based on resource availability and requirements. Protecting scheduler operations includes isolating sensitive workloads and ensuring decisions are made based on secure and trusted inputs. Kubernetes interfaces with the container runtime to manage containers' lifecycle on its node. Security measures include using authenticated and authorized communications with the API server, alongside securing the node's access to prevent unauthorized command executions. The container runtime is responsible for running containers. Enhancing its security involves using trusted base images, scanning for vulnerabilities, and employing runtime security tools to monitor and enforce security policies on running containers. Kubeproxy manages network communication within the cluster, implementing services network rules. Securing Kubeproxy involves restricting access to the network interfaces and applying network policies to control traffic flow securely. Pods are the smallest, most basic deployable objects in Kubernetes, encapsulating one or more containers. Pod security is crucial, involving practices like defining security contexts, using pod security policies, and minimizing the use of privileged containers. etceterd, the primary data store for Kubernetes, holds all cluster data. Ensuring etceterd's security means encrypting data at rest, restricting access through RBAC, and using TLS for all communication to prevent data interception and tampering. Container networking enables communication between pods across the cluster. Securing it entails implementing network policies to define how pods communicate, preventing unauthorized access and ensuring data isolation. Output. Client security involves securing the interfaces and methods through which users interact with the cluster, including kubectl and the API server. Techniques include using strong authentication mechanisms, implementing role-based access control, and regularly auditing access logs. Kubernetes supports various storage options, from local storage to cloud provider volumes. Securing storage involves encrypting data at rest and in transit, plus ensuring proper access controls are in place to protect sensitive data.